Hey guys, in this video we're going to look at the 2022 AP Calculus BC exam first response question number 2. This is actually a pretty straightforward parametric problem. And with that said, let's just jump right in. The question reads, a particle moving along a curve in the xy plane is at a position x of t, y of t at time t is greater than 0. The particle moves in such a way that dx dt is equal to square root of 1 plus t squared, and dy dt is equal to the natural log of 2 plus t squared. At time t equals 4, the particle is at 0.1, 5. Part A says, find the slope of the line tangent to the path of the particle at time t is equal to 4. The slope of this tangent line is the instantaneous rate of change in y in respect to x, or dy dx. We can find this by dividing dy dt over dx dt. And since we want to find the slope at time t equals 4, we'll evaluate this dy dt over dx dt at time t is equal to 4. In our calculator, I'm going to store dx dt in y1 and dy dt in y2. And we're going to evaluate y2 at 4 divided by y1 by 4. As always, I recommend giving complete answers. So the slope of the line tangent to the path of the particle at time t equals 4 is 0.701. Moving on to part B, it says find the speed of the particle at time t equals 4 and find the acceleration vector of the particle at time t is equal to 4. When we talk about the speed of an object versus its velocity, the velocity is a speed with direction. Or you can also say that the speed is the magnitude of the velocity. So I'm going to start with the formula that shows that the speed is the magnitude, or the square root of dx dt squared plus dy dt squared. Again, we need to evaluate this at time t is equal to 4, so we'll bring out our calculator and do square root of y1 of 4 squared, y2 4 squared. And I get 5.035. So the speed of the particle at time t is equal to 4 is 5.035. The second part is asking for the acceleration vector, also evaluated at time t equals to 4. The acceleration vector is the double derivative of x in respect to t, the double derivative of y in respect to t. So we can write the acceleration vector as a force given by x prime of 4, y double prime of 4. Let's bring out our calculator and calculate this by going to math and derivative of y1, x at 4, and also the same but for y2. And there's my acceleration vector. So the acceleration vector of the particle at time t equals 4 is 0.970, 0.444. Part C, it says to find the y-coordinate of the particle position at time t is equal to 6. Since we're only dealing with the y-coordinate, we can disregard the dx dt. And the problem gives us a starting point, which is the location of the particle at time t equals to 4. Since we're looking for the position of the particle at time t equals to 6, all we need to find is the displacement of the particle, or how much the particle moved from time t equals to 4 to t equals to 6. When we write this out mathematically, we can say that y of 6 is given by y of 4 plus the integral of dy dt from 4 to 6. Again, this y of 4 represents the initial position of the particle at time t equals to 4, and this integral of dy dt represents the overall displacement of the particle from time t equals to 4 to t equals to 6. Based on the information given, we know that y of 4 is equal to 5. So using our calculator, y of 6 can be calculated by doing 5 plus math FNINT of y2 x from 4 to 6. It comes out to 11.571. So the y-coordinate of the particle's position at time t equals to 6 is 11.571. The last part of the problem asks us to find the total distance the particle travels along the curve from time t is equal to 4 to time t equals to 6. The total distance traveled is the integral of the particle's speed, which again is the magnitude of its velocity. So we evaluate the total distance traveled from time t equals to 4 to t equals 6 as the integral of the square root of dx dt squared plus dy dt squared from 4 to 6. And we can easily evaluate this using our calculator by going to math FNINT of square root of y1 squared plus y2 squared comma x from 4 to 6. And we get 12.136. So the total distance the particle travels along the curve from time t equals to 4 to t equals to 6 is 12.136. Alright, so that was 2022 AP Calculus BC first response question number 2. Hope you found this video to be helpful. See you in the next video.